Greetings, fellow humans, and a very warm welcome to my first video. Thanks for showing up. In this video, I'd like to present to you a rather radical, some would say game-changing system for safety-critical software development that involves nothing more than plain text and open source software. First, a little introduction. My name is Ed Liversidge, and I'm the Managing Director and CTO of Harmonic Software Systems, a software engineering company based in the UK. I've had my company for the past 24 years, specializing in embedded systems, real-time operating systems, and for the past 8 years, testing and certifying safety-critical aerospace systems. I've been programming since I was 11 years old, and I've been using the Emacs editor since 1995. In my company, all my engineers use a variant of Emacs called Spacemacs. So, DO-178 is in the title, but what is it? I posed this question to my AI, which has been trained on the DO-178C standard, which we've called the virtual DER, and the answer it gave was this. DO-178C, titled Software Considerations in Airborne Systems and Equipment Certification, is a document that provides guidance for the aviation community on how to ensure that the software aspects of airborne systems and equipment comply with airworthiness requirements. The key here is that it provides guidance. It does not define a process. That process is left to us to define. It does, however, define objectives that need to be met. For example, the high-level requirements are developed. And it defines outputs that need to be produced. For example, the software requirement data. So, in this short video, I'm going to look at the current DO-178C toolset, address the shortcomings that I see there. I'll explore why using plain text for DO-178C is so powerful, and then I'll give you a brief demo of what I've done so far. So, the current toolset as I see it, and all of this is in my experience. It could be that you've got a completely different experience, and I'm sure you'll let me know in the comments below. But, for the last 8 years, I've been working on DO-178, and this is what I've seen. The industry standard for requirements management is DOORS. That comes from IBM. Or there is another tool that I've seen used called Polarion. There are obviously lots of other tools, but these are the two I've got most experience with. You have Microsoft Word, in which all the documents are written. In DO-178C terms, you have the PSAC, which is the Plan for Software Aspects of Certification, the Software Development Plan, the Software Verification Cases and Procedures, and all those are in Microsoft Word. Microsoft Excel is often used to track the review process and to describe the traceability. In my experience, Polarion is better for the traceability. For version control, you can have a mix of Perforce and Git. And then DO-178 demands that you have problem reports to fixed issues, and people often use Jira for that, or I've seen Polarion used for that as well. And then email is the tool which ties together all the discussions and everything that's going on between individual engineers. Now, the current limitations as I see it is that DOORS needs a server. That's usually on a VPN. My experience with it is that change control can be a little bit difficult. It's a very good tool. It's an industry standard, but still working out when a change was made, who made the change, why the change was made can sometimes be a bit difficult. And it's just a tool for requirements. Polarion, again, very good tool. Again, that uses a server. It will export all the artifacts as a PDF. The trouble is that when you export it as a PDF and you give all this DO-178 information to the customer, all the links in there are pointing to the Polarion server, which is behind the VPN. So suddenly all the links are broken. Your customer looks at it and all they've got is a load of flat text that they can't link to. The change control, especially working out the differences between different versions, can be very difficult with Word and Excel. You can turn tracking on. That gives you a huge list of changes, red line changes. If you turn the tracking on 4 weeks ago and then finally the document is done. Diffs are possible, but then you need to have 2 versions that are saved, and it's just tedious to do diffs in Word. Emails can get lost Companies can have a retention policy so that you come back a few years later to track a discussion that was going on, and all the emails have been junked. And none of these tools integrate or communicate with each other very well. So they're all kind of siloed tools to get the job done. Now, as a company, we can offer two solutions. The first solution is what I see for the small to medium enterprise. It works best with smaller teams, maybe up to 12 people. That solution is what I'm talking about today in this video. That's plain text plus Spacemacs plus Git. The other option for large and enterprise companies is to use IBM's ELM suite. ELM is Enterprise Lifecycle Management. And that consists of doors, but in addition to doors, it integrates very well with Rhapsody, which is a design tool, model-based system engineering. It can also generate source code. And then workflow and test management tie those together to give a unified framework for managing the document. But it is big, it is heavyweight. So it's good for big companies, it's good for enterprise. It's probably not so good for the small company. So in this video, yeah, we're going to focus on the use of plain text within DO-178C. And what I'll hope to do is to show you how this is an extremely powerful solution for you to use. I'm going to go into the advantages of plain text. First of all, it's timeless. ASCII text has no reliance on any format other than ASCII. It will never be phased out. It will never become outdated. It's always readable, so by either a human or by an AI. There's no web server involved. You can read it using just Notepad if you want to, but at least you have that option. You can just open up the files, you can open up Notepad, you can see everything that's there. The big advantage, which we will see in later videos, but which really was the driving force for this approach, is the benefit of having a large language model or an AI easily read and understand all the DO-178C documents. So they're not hidden behind proprietary formats. They're not hidden behind web servers, not hidden in Word or in Excel. They're all there for the AI and the human to look at. They're searchable with multiple tools. For instance, grep, ripgrep, even find. So you can find anything you want just with a recursive grep or with a ripgrep or something. And if you compare this with trying to find a piece of information which is hidden in a Word document, you have to open the document, you have to guess which one it's in, do a Control F, search for what you're looking for. All this is tedious. Much better to have everything searchable. The final point is that it is parsable by Python and the AI. So on my last project, we had Python scripts that would read plain text documents out of the SVCP, so that's where all the verification cases and procedures are stored, and it would actually pull out the expected results on a test run and compare that with the actual results and then give you a pass or a fail. So that was very powerful to extract that out of your SVCP. Just going into Git. So I'm sure everybody's heard of Git, but just in case, searching the web, the explanation for Git is that by far the most widely used modern version control system of the world today is Git. It's a mature, actively maintained open source project originally developed in 2005 by Linus Torvalds. He's the famous creator of the Linux operating system. So it's been there a long time. It works. Linux has got over 2 million lines of source code, and it's a massively distributed way of tracking this information. It's incredibly powerful. It's even more powerful when we integrate it with our tool of choice, Spacemacs, using a plugin called Magit, which I'll go into in another video. But the integration is there and it's fantastic. So yeah, as I've been alluding to, Spacemacs, what is Spacemacs? This is the company tool of choice. It's a fork of the mighty Emacs text editor. It's got over 40 years of development behind it, and it's still going strong. It's powered by Lisp, which is a programming language that allows for powerful customizations and packages to be developed. two of which we will make extensive use of today. The first one that we're going to use is a package called org mode. The second one is a package called org roam. So org mode is a very powerful markup language. It's very simple to understand. It's very powerful to use. It can also be used for task and time management. And you can even use it as a framework to execute code from within. I'm going to show that in a little bit as well. Org roam, which we'll go into in more detail in the next video, that provides a powerful deep linking system between all the documents and also gives you visualization so you can see the traceability, which is very important for DO-178. So now I'd just like to just show you a quick demo of Spacemacs. Let me just point out, this is all work in progress. There are still kinks to iron out, more learning to be done, more refinement to be done. But in any case, I hope it will become obvious what a powerful process this is. So the first thing is a quick through of Spacemacs, org mode and traceability. Now, just as a side note, in Spacemacs, which is this tool you're looking at now, this presentation is actually being delivered in org mode. So you've already seen the tool. But I'm able to use the built-in spell checker. And that works on every word that we write. So every single document, every single test script, every single source code comment is going to have this spell checker on it. So that immediately saves a ton of work where you have a PR where there's been a spelling mistake and you have to update a document. So that's the first thing to point out. So I'm going to open the PSAC for what is our current project, because my company is developing a certified bootloader that we're writing in Rust. And I'm using this framework as an exercise to manage that development and to get it certified. So let me open the PSAC. The link is here to open the PSAC. As soon as I click this link, there's the PSAC that opens. So just to quickly show you what you can do in org mode, you see these are just the headings at the minute. I can navigate up, navigate down. I can open a heading pressing tab. I can open all headings and cycle through them by clicking Shift and Tab. So this is the PSAC, and just as an aside, this was all generated by an AI with a simple prompt. So again, that's for future videos, but in terms of getting the groundwork going for DO-178, this is fantastic. So one last point on this. So you might be thinking, okay, great. So it's all in org mode. That doesn't help me. I'm not going to use Notepad to see what's going on, but I can quite easily export from org mode from this document into a PDF document, a LaTeX document, an ODF file, which is compatible with Word, or even HTML. So I can quickly do that just by clicking this command, comma EEHO. Let me do that, comma EEHO. There we go. And this has just popped up. This is what it's created for the HTML. So I've been able to format the HTML and give it this look and feel, which is fantastic. So everything will be able to export to HTML or to whatever format we like. Now, oh yeah, let me just go back to this because I just want to quickly show you with these headings. They're called drawers in Emacs speak. But what I can do is I can move them up and down very easily, like this. I can promote them very easily, like this. So that gives me an awful lot of power. Close them all down to give a nice top level view and just revert everything to undo any changes. So next I'm going to show you the software requirements documents. Here we go. And again, we can tab these open and closed. I've got various bits of information here just to remember. DO-178, high level requirements, low level requirements, what is a good requirement, what are the different LLR types I've defined, introductions, etc. But the bit I want to focus on is the software requirements, because you will notice this open tag, which is at the beginning of this high level requirement, these two to-dos. And what I'm able to do is to configure these however I want. So in this instance, I've configured it to go from to-do AI, to a to-do AI review tag, open, waiting, deleted, etc. I can show that with this. So if I do shift right, that cycles through all the different states that it can be in very easily. If I open this tab, you will see I can go from open state to waiting, to deleted, to reviewed, to done, and those are all tagged with this time tag, which is very good just for tracking what's going on. Also, just notice this at the end, Bob, that tag tags the person who is currently working on this particular piece of work. And I can use that, I can filter it, and I can assign people and different tags to all these different pieces of information. So, yes, let me show you that. I'll show you the agenda. So I can just open this, I can do comma, A, T, and this shows me all the open or to-do items. In fact, all the items throughout the entire project. So as you can see, we're open currently with these low-level requirements in startup.s to do various things like disable the MEU, disable the instruction cache, disable the data cache. It's incredibly powerful because I can just do a capital F. This puts me into follow mode. Up and down will then open and go to the particular file where this information, where this task has been put. Very powerful. Press Q to close, and then we're back here. Okay. Now, links. Links are a very powerful feature found in many documentation systems. They work very well in org mode. Let me show you the links. I think what I will do is I will just split this, open this, so that then at least you can see the presentation and the requirements. If I open this drawer here, you see that the high-level requirement, HLR 009, which is that it shall initially execute ARM assembler code, that is implemented by this requirement, low-level requirement, LLR1. This is a file requirement, so I'm defining that there will be a file called start.s. Now you notice it's got this blue color with the underline. That is a link, and we use the power of org mode and indeed org roam to have these deep links. I can toggle this because what you're seeing at the minute is the human readable version of the link. Comma, capital TL shows this ID, and then the human bit, the text bit. And this ID is a unique ID, so even if things get moved around, the ID remains the same and the links are still intact. So if I just turn that off, comma capital TL to go back, then I press enter, this will then open LLR1, which is this file here. Now, notice that this is bidirectional traceability because I've put a link back up to the source high-level requirements, HLR9. So I can click that and go up. I can click this and go down. So I can open this drawer with the tab key and expose the function. So at the top, we've got the file. One layer down, one level down is the function requirement, which inherits the number of the file requirements, which is 001, sticks a 0.01 on the end, and then defines the functions that are in the file. And then I can tab this open and we have these implementation requirements. And that's the individual bits, of design which are going into the function which are part of the file. I hope that all makes sense. So that's the format I've chosen to implement: the file, the function, and then this implementation LLR. Now, I've put that into this snazzy little document here just to try and explain the relationship. This example imagines you've got a math library, which is the high level requirement. The low level requirement is that you will have math.c, that's the file level. Then that is encapsulated by the functions. In this case, we have two functions. We have sine and we have cosine. And then another level down, we have the implementation. I don't know what that implementation is. I'm just making this up. But anyway, so I did mention previously that there were ways to execute code from within these org files, and I'm going to give you a demonstration of that now. I'm going to open this requirement, which is the implementation requirement 4, which, if I follow this down, takes me to here, which is that we shall disable the MMU. Notice as well that all of these bits of design information were also generated from our AI. It's not that I'm saying that we put source code in the design, of course we don't, but I'm using the AI to give the designer a heads up on how you might disable the MMU, in this case for the Cortex A53 processor. So that's a very powerful way just to get some information into our SVCP for a human to then look at and see if we're on the right track. But the bit that I want to show you is this sequence diagram. Again, this was generated from the requirements, but this is GraphViz, and this GraphViz code can be executed to produce this GraphViz sequence diagram. I've witnessed engineers spend countless hours moving boxes around in design documents, squeezing them in, changing labels, etc. in Word due to a requirements change that goes through a meeting and a decision process and a PR process and all of that. And when I saw them, I thought there must be a better way. And this is the better way. I think those days are over because we can now auto-generate all our designs, either UML designs or sequence diagrams or whatever you want, using this system. So I'm just going to demonstrate. You can see that in this particular diagram, I've got the check 4K alignment. That's for this requirement here, 1.01.01. Then I've got another requirement, which is to disable the data cache. That's 1.01.06. And let's say I just want to move all this lot down 1. So I want 06 to be aligned with 02. Now, this might be a real pain to do in Word, but in this situation, it is dead easy. All I have to do is change that to a 2, do Control C, and there you go. It immediately gets regenerated and moved down. So if you find that you want to add in another requirement and you are quite happy to move down the numbers, it's not a case of opening Word and getting all of these boxes and changing them all. It's more a case of a search and replace in code in order to make the change. I'll just put that back. I'll save it, Control C, and up it moves. It's fantastically powerful, amazing. So we're near the end. You're still here, obviously. Let me say a big thank you to you for sticking with me till the end of the video. Also, I would like to say a big thank you for David Wilson over at systemcrafters.net. He has got a bunch of fantastic in-depth videos on Emacs, on org mode and org roam. And these have really helped me to produce this content. So thank you, David. I bought a hoodie to say thanks. For more information or to arrange a more in-depth demo, you can easily go to my contact page on the website, book an appointment, and I'll be more than happy to explain how this system is going to massively cut your certification costs. Also, have a look at our white paper. Fix, develop, and test embedded software in a game changes way. Absolutely crammed full of all the information, all the tools that we use in our DO-178 process. And that's kind of essential reading to understand what I'm doing here. We use this system for all our customers. So again, please do get in touch. So in the next video, I'm going to focus more on applying what's called the Zettelkasten note-taking system to DO-178, and that uses org Rome. And then I'll use that as a foundation for subsequent videos to showcase how we use large language models to do the heavy, tedious listing that is in the DO-178 process. So thanks again. Until next time, bye-bye.